Moving on in chapter 5, going to section 4 here. Solving special systems of linear equations. We've already sort of covered this within some of our previous notes and previous assignments, but these are the formal notes over it, so we're going to learn a little more in depth about it today, get an assignment over it, and then we'll be done with 5.4. So special systems of linear equations. You guys remember when we had parallel lines? What was my solution when I had parallel lines with systems of equations? No solution. That's one of our special systems of linear equations. What happens if I had the same line? The two lines were the same. Infinitely many solutions because they're intersecting at every single point. Okay? So, that's what today is all about. Just like we talked about, a system of linear equations can have one solution, no solution, or infinitely many solutions. If it has one solution, the lines are just going to intersect at one point. Whenever you solve it by substitution or elimination, you're just going to get an x value and a y value, just that one ordered pair. That's our one solution. No solution, we already talked about it. If you get parallel lines at all, we're looking for the point of intersection. Parallel lines will never intersect. So I don't have a solution. No solution. And infinitely many solutions. The lines are the... So, if the lines are the same, infinitely many solutions. Our points are intersecting at every single... Or our lines are intersecting at every single point. Those lines go on forever and ever and ever. So they're intersecting. They have infinitely many solutions. If I have no solution, it's parallel lines. What do we know about slopes of parallel lines?
They have the same slope.
Same slope. What about their y-intercepts? Do they have the same y-intercept? No, they have same slope. Different y-intercept. Infinitely many solutions. It's the same line, right? Do they have the same slope or different slopes? Same slope. What about y-intercept? Also the same. So if you get an equation, you see that it has, or a system of equations, you see that it has the same slope. Two lines have the same slope. And a different y-intercept. Before you even graph, you should be able to recognize that, hey, these are going to be parallel lines. I'm going to get no solution here. I still want you to graph it, but you should be able to still recognize that. If you get two equations that have same slope, same y-intercept, it's the exact same line, you should be able to recognize, hey, this is going to be infinitely many solutions. If you have one solution, they're going to intersect somewhere. So do these have same slope, different slope? Different slope. And I'm not going to write anything for the y-intercept because they could have the same y-intercept. They could have a different y-intercept. Just depends on what the equations are. But you will sure have different slopes if you get one solution. Everyone okay with that? So one solution, different slopes. No solution, same slope, different y-intercept. Infinitely many solutions, same slope, same y-intercept. Okay? Any questions about our three different types of solutions with systems of equations? All right, let's jump into some examples. I got two examples for you, but we're going to solve them using all three methods. We'll solve first using graphing, then using substitution, then using elimination. Okay? So y equals 2x plus 1, y equals 2x minus 5. Y equals 2x plus 1, y equals 2x minus 5. What do we notice about these slopes?
They have the same slope.
Same slope. What do we notice about their y-intercepts? different y-intercepts. So before we even solve anything or graph anything, what can I say about this system of equations if it has the same slope and different y-intercept? No solution. These are going to turn out to be parallel lines for us. Let's go ahead and see what it looks like graphically, though. First equation, what is my slope? 2, which is what over what? 2 over 1. And what's my y-intercept? 1. We still okay at recognizing slope and y-intercept. What do we graph first? The y-intercept is crossing my y-axis at 1. So go up 1 on the y-axis, put a point. Slope, it's 2 over 1. Rise over run, positive 2 over positive 1. Which two directions, how many units? Positive 2 over positive 1. How many units? Which two directions? Up 2, right 1 from my y-intercept. So up 2, right 1. Up 2, right 1. Are we okay getting more points using the slope? What other two directions can I go? Down 2, left 1. Connect your points. There's your graph of equation 1. Any questions how we got that? Okay, we said same slope for the second equation. So 2 over 1. What's the y-intercept of the second equation? Negative 5. So once again, graph the y-intercept first. Down 5 on your y-axis. Up 2, right 1. Once again, same slope. And once again, down 2, left 1. As we predicted before we even did the problem, these are parallel lines. So what would I put if I get parallel lines? No solution. Any questions on what parallel lines comes out to be? Everyone knows how to handle it if you get parallel lines. Okay, can I erase this and solve using substitution so we can see what it looks like when we get no solution with substitution? Okay. Okay, this is a brand new problem, quote unquote, wants to solve using substitution now. When I'm solving using substitution, what do I need to do? Substitute what for what? Yeah. You first want to make sure that at least one of your equations is solved for a variable. That's already done for us. Here it's saying y equals the whole expression 2x plus 1. Y and 2x plus 1 are interchangeable. They're the same. So what can we substitute for this y right here? 2x plus 1 equals 2x minus 5. We okay with that? Now we've got an equation with just x's in it. So I'm going to try to solve my equation for x, try to get x by itself. What would be my first step to do that? Subtract 2x from both sides. What happens? They cancel completely out. My x's are gone. What's left on the left-hand side of the equation? 1. What's left on the right side? negative 5. So, sometimes when we're solving a system of equations, our variables will cancel completely out in our equation when we're not left with any variables as of right now. So, we've got to look at the statement that's left over. 1 equals negative 5. Is that true or false? False. If your variables cancel each other completely out, you're left with a false statement. We already know the answer, but what is it? No solution. So, variables cancel each other out. You get a false statement. No solution. If you're solving using substitution. Everyone okay with that? Can I erase and move on and solve by elimination now so we can see what that looks like? Okay. I'm going to go ahead and line up our x and y values for us. So I'm going to subtract 2x from both sides on each equation. So it'll be negative 2x plus y equals 1. Negative 2x plus y equals negative 5. So that's what those equations will be if you solve them or put them in standard form, which is the form we want them in for elimination. All right, elimination. How would I solve this using elimination? Yep.
Multiply 1 by negative 1.
Very good. In front of your x's, you've got same number, same sign. We want same number, opposite sign. So I can multiply one of my equations by a negative 1. Does it matter which equation I do? No. Do you want to do top or bottom? Top. Let's multiply the top by negative 1. It's going to change all my signs. If it's a negative, it becomes a positive. Positive becomes a negative. So negative 2x becomes 2x. Positive y becomes negative y. Positive 1 becomes negative 1. Do we now have same number, opposite sign?
Yeah.
Yes, we do. Once we have that, we can add our two equations. What's negative 2x plus 2x? What happens to the x's? They're eliminated. What happens to my y's? Y plus negative y. They're also eliminated. So, if both of my variables get eliminated, what would be left on that left-hand side? Nothing. What number represents nothing? 0. What's negative 5 plus negative 1? Negative 6. So, for solving using elimination, and we get the no solution, special solution here, both your variables are going to cancel out like we just saw. And 0 equals negative 6. Is that true or false? False. So you're going to get a false statement. So once again, it is no solution. Everyone okay with that? Any questions, comments, concerns, or confusion on what no solution looks like when you're solving by graphing, substitution, or elimination? Graphing, you're going to get parallel lines. Substitution, when you substitute, that variable is going to cancel out. You're going to be left with a false statement. Elimination, both variables are going to cancel out. Once again, left with a false statement. Any questions about that? Can I move on to our second example to solve all three ways?
Yeah.
Last example here.
Yeah.
Solve the system of linear equations. Negative 2x plus y equals 3. Negative 4x plus 2y equals 6. What form do I want the equations in to graph easily? Slope-intercept form, so I need them solved for which variable? Solve them for y. So, negative 2x plus y equals 3. How would I solve this top equation for y? Add 2x to both sides. Bless you. Bless you. Bless you. Can I combine a 3 plus 2x? No. So you can write it as 3 plus 2x or 2x plus 3. Equation 1 is now solved for y. Equation 2, how would I get that solved for y? Add 4x to both sides. Can we combine a 6 plus 4x? No, I'm going to write it as 4x plus 6. Next step to get y by itself. Divide everything by 2. 4x divided by 2. 2x. 6 divided by 2. 3. Okay. Before we get into even graphing, substitution, or elimination, what do we notice about these slopes and the y-intercepts of these two equations? Same slope, same y-intercept, right? So what conclusion can we draw before we even start solving? IMS. I still want you, whatever method you're using, I still want you to go through that method even though you know what it's going to be. Does that make sense? I don't want you to just jump straight to it and say, oh, it's got same slope, same y-intercept, so I know it's infinitely many solutions, so I'm not going to solve it at all. Still want you to graph it if you're solving by graphing, use substitution or elimination. Still want you to look through that process. So, both of these, what's my slope? What's my slope? 2 over 1. Negative 2 over negative 1. And what's my y-intercept on both of them? 3. Excuse me. We're going to graph our y-intercept first. Go up 3 on the y-axis. And then 2 over 1, same slope as we used earlier. Go up 2, right 1. From your y-intercept. You can also go down 2, left 1. So, this is both of my lines graphed on the same graph right now because they're the same slope, same y-intercept. So if we get the same line, once again, what's our answer? IMS, infinitely many solutions. Because we're looking for the point of intersection, these two lines are intersecting at every single point, forever and ever and ever, because they're the same line. Any questions what infinitely many solutions looks like graphically? It's just going to graph the same line. Okay? Can I erase and solve using substitution? Okay. For substitution, you want an equation solved for a variable. We've already done that. So let's say I started off using substitution and I solved my top equation for y. Okay? What does that top equation say y equals? 2x plus 3. So in this equation 2, what can I replace this y with? The expression that it equals, 2x plus 3. The rest of the equation stays the exact same. Just take y out, put 2x plus 3 in its place because 2x plus 3 equals y. They're interchangeable with each other. Any questions on what I've done using substitution here? Now we've got an equation with just x in it. So we need to solve for x. What would be my first step to do that? Distribute. 2 times 2x, 4x, 2 times 3, 6. Next step. Combine like terms. Negative 4x plus 4x gives you what? 0. They cancel each other out. Big surprise there. So, just like earlier, when we were solving using substitution, our variable cancels each other out. What statement am I left with? What's left on the left-hand side? 6 equals 6. 6 is left on the right side as well. Is this a true or false statement? True. So if your variables cancel each other out, you're left with a true statement. That's when you get infinitely many solutions. Any questions, comments, concerns on what infinitely many solutions will look like using substitution? When you substitute, you'll get that variable canceled out. You'll be left with a true statement, so infinitely many solutions. We get with substitution here. All right, can I erase and solve using elimination now? So we can see what that looks like. Okay, everything's lined up where it needs to go. We want same number, opposite sign in front of one of my variables. So do you guys want to eliminate x or y here? Let's try eliminating y. So in front of y, we've got positive 1 and positive 2. Can I multiply the top by anything to get 1 to 2?
Yeah.
Yeah, what can I multiply by? 2. Very good. Negative 2. They have same sign right now. So I need to make it a negative 2 so they'll be opposite signs when I multiply through. Any questions about that? Okay, the whole equation gets multiplied by negative 2. Negative 2x times negative 2 gives me positive 4x. 1y times negative 2 gives me negative 2y. 3 times negative 2, negative 6. In front of y, we now have same number, opposite signs, so I can now add my two equations. As we probably guessed, what happens to my x's here? Negative 4x plus 4x. They're canceled out, they're eliminated. 2y plus negative 2y, what happens there? They're also eliminated. So on the left-hand side, what am I left with? After everything cancels out? 0. Equals, what's 6 plus negative 6? 0. So, when you're solving by elimination and you get the special solution, infinitely many solutions, all your variables are going to cancel out. 0 equals 0. Is that true or false? True. You're going to get a true statement out of it, and that's when we get infinitely many solutions. So, infinitely many solutions. When you graph, you get the same line. When you substitute, that variable is going to cancel out. You're going to get a true statement. When you solve by elimination, all the variables are going to cancel. You're going to be left with a true statement in the end. So false statement, no solution. True statement, infinitely many solutions. Questions, comments, concerns? How do we feel about this? It's probably good that we've seen it earlier on as well. Here's your assignment. Pages 249 through 250. Numbers 2 through 26 evens. It's about 13 problems, I believe. Make sure you get the correct heading on your paper. Name, date, period, assignment, upper right-hand corner. Remember, I need to see this when you turn it in on Canvas. Make sure you read the directions and solve using whichever method they tell you to use. If it tells you to choose any method, you get to pick whichever method you want to use. Okay? If there's any graphing ones, I do have some graph paper over here. But if you're going to do graphing, I want it to be on some sort of graph paper, whether it's your own or mine. Okay? Any questions about the notes before I end the recording?